Perfect. Thanks, Glenn. And again, thanks to everybody from the Center for Business Analytics. As a multiple time alum of the University of Cincinnati, I certainly appreciate this opportunity to talk about some of the work that we've done, and hopefully in a means that's helpful to academics, business people from all industries, not just those who know a little bit something about sports, though I'm sure some of these stories, some of these anecdotes will resonate a little bit more with some than others. But my interest, both in this conversation and just in general, is the application of the different work that has been done and that can be done, and how that can improve any of the processes or work that any of us would do. Moving into overall agenda, we'll have about, to Glenn's point, about 40 minutes here to talk. There will be a Q&A toward the end. I want to get in a little bit into what is data science. I'm assuming this audience and the Data Science Symposium knows about that to a great degree, but more so why sports is very relevant at really carrying the flag or setting the stage for the revolution of data science that we've seen over the last 2 decades, and how paying attention to what's happening in sports actually can continue to really help guide where innovation will exist in the future of business and how data science plays a role in that. I will get in a little bit of a soapbox. Obviously, war is bad, can be used to mean several things. In this case, I explicitly mean it related to sports. But I want to talk for a few minutes about how oversimplification, how simplification is good, but oversimplification is bad. So we'll get into a really good example of an anecdote of how sports overall can illustrate the positives and the negatives of trying to overly simplify any kind of action or any kind of problem or solution for a problem into a metric or few. I do want to then talk about several sports examples that match up with the lessons that I've learned. You'll hear a little bit about my background here in a second, but as Glenn mentioned, I've done data science and predictive and prescriptive for, it'll be 17 years now since I started. 2004 was my first year, which happens to also be the same year that the movie Moneyball is about. So I was doing a lot of the same things over time. And now that I'm taking that to other industries in the consulting world across several different industries, and with Coterie now as an insurance company and an insurtech company, certainly want to talk about what I think I've learned in perusing and evaluating data in sports that's applicable to things well beyond the sports world, and what's going to happen with a fantasy team or our individual favorite teams overall. Generally, kind of quick introduction here, but I think this sets the appropriate stage. As I alluded to, 15 years in sports analytics. I started working for a startup called whatifsports.com, which does still exist right now. It's owned by a company called Sports Hub, which was all about theoretical sports. It was what would happen if the big red machine of the 1970s played in a game against the Bronx Bombers of the 1920s. Let's build a simulation model to actually figure out, see what could potentially happen. That company started in 2001. It was actually sold to Fox Sports in 2005, and I was a part of that acquisition, and enjoyed working still in what felt like a more of a startup environment for a while after that. What we ultimately found in doing sports simulation analysis, especially as my UC quantitative analysis MS degree started to kick in, and I learned more and more about the different types of applications of the math that we could use, is that we weren't just a company that was good at figuring out the barstool debates between the best players in certain leagues and the history of certain games. If we built the simulation models appropriately, we got really good at figuring out what was going to happen. And what was interesting about that, a couple things. One, obviously the fantasy sports space, fantasy football, basketball, baseball, was certainly starting to take off with technology around that time. So people wanted to know, the average fan in general, fantasy sports became ubiquitous to the point that they wanted to know, is my team going to win? And that meant not just is my team, the local team that I grew up cheering for, going to win, but is the team that I built for my fantasy team going to win as well? And who should I have on my team? So while that was also happening, I knew nothing about the sports betting and wagering space. I didn't know what the spread was. I didn't know what any of the words associated with that space meant. and yet realized, as others were starting to reach out to me, that our predictive technology could potentially disrupt that entire marketplace. Fox itself wasn't specifically interested in going into that space at the time, which makes sense given that when sports betting was illegal in almost all states back in 2000, in the early 2000s, that with the relationships with leagues, they wouldn't want to do that. It's a different story now, not for this conversation. But I was intrigued with the space enough to know that I wanted to spin off and found my own company that was heavily focused on treating the sports world, the sports market, as a market, almost like a financial market, and leveraging data and technology and the convergence of those things to get it right and to be predictive. And what we found was we flipped the entire industry on its head. In fact, it's the thing by far I'm most proud of, is that when we sold Prediction Machine, technically back in 2016, I had an earnout through 2018, which is why it says that on here. But when I sold Prediction Machine, the editor-in-chief of ESPN at the time sent me a text that said, "You changed an industry." And I don't think we could have received a better compliment, because we took something that had kind of lived in the shadows and shined a very academic and scientific light on it, and really helped to define the entire industry as it currently exists, certainly now more so in a regulated world. Not going to spend as much time on the rest of the things in this introduction, but there are parallels to everything I just said, aside from the fact that regulation has existed in insurance for hundreds of years, at least in this case. But there are significant parallels in terms of where I am today and the time that I started in the sports world. Sports just moves, and we'll see why here in a second, but moves so much quicker. Love the partnerships I had. I've done over 8,000 radio and TV interviews, generally on radio, across being able to answer any question. That was the beauty of what we did with predictive analytics in sports and Prediction Machine, the company that I spun off with, or that I worked on and built with my brother, is that we could answer any question. I could get on the air in Laramie, Wyoming, and tell them what the score between the Wyoming Cowboys and the Boise State Broncos would be. Without having to know, I usually did, but that's my own problem, but without having to know anything specifically about any of those individual teams. And that allowed us to be able to be a great asset to media partners, obviously within the betting and fantasy space, to other partners as well along the way. Since selling the company, as mentioned, I'm obviously part of Coterie now. But previous to that, worked in the in the consulting environment. Many different organizations that our consulting company, Amend Consulting, worked with. From a data science perspective, a previous colleague and a good friend of mine, Doug Miser, is now running that business as well. Certainly recommend for the mid-market space the kind of work that Amend has done and is doing in the data science field. Getting back to my startup roots now. But consulting was a great place to live for a few years. And for those out there, especially who are relatively new to potentially data science roles, I started, as you can tell by hearing that story, focusing on passion of mine, taking the things that made sense to me related to data and business, and which was usually sports. Batting averages made sense to me. And so everything was always kind of through the lens of sports. And while I set out to chart my own path related to data science and my passion, after selling that business, my goal was to only try to work on and solve problems that were interesting to me. Well, it turns out, as I found in the consulting world, and now that I'm in insurance, that as long as there is an appetite, or at least an ability to change, and a good set of data or information, to a data scientist, at least to me, just about every problem seemed interesting to me, and every problem seemed like something I wanted to try to solve. And so for those of you, and I've done had a lot of conversations recently with recent grads or people just trying to figure out their path within data science, consider that. Obviously, passion is important, but the box from which or by which you need to hold yourself, that you might hold yourself, doesn't need to be that rigid when you're thinking about trying to solve problems with data, as long as you have some autonomy or some ability to actually make an impact. Cool. What is data science? This is my definition. I'm not trying to say that this is anything other than an academic definition or anything specific to an academic definition. This is just my perspective, but it's how I would usually try to sell data science, because ultimately we're talking about using technology and information or data to make efficient decisions. It's what we're all trying to do in our minds. It's what we're all trying to do with every decision we make, whenever we make decision. It's what every executive wants to be doing, is make efficient decisions. I just realized really early in life that, and fortunately right around the time when the convergence of technology and information made a lot of this possible, that I didn't want to sit around and watch tens of thousands of hours of football or baseball or basketball just to figure out the sport, like a lot of coaches have done to be able to make the decisions that they make. I realized that with data and technology, that objectivity could win over bias, that we could actually we could solve problems and come up with answers to the problems that, you know, plagued a sport or plague any of our industries without needing to spend countless amount of time trying to figure out how to make those decisions. Again, it's the best way and the most appropriate way at this point that I've been able to identify to make those efficient decisions. With that, information is king. The more data, generally, the better, at least contextually. I mentioned objectivity wins out over bias. I cannot stress that enough. That our own personal biases, especially in the world, in industries like sports that have done things the same way for such a long period of time, that we all have preconceived or are predisposed to our own biases. So being able to leverage data and technology really helps with that. Automation is the key to scale. I talked about this a lot when looking at potentially selling my business, but Prediction Machine came up with simulated outcomes, 50,000 simulations of every possible outcome, or of every game that was on the schedule for over 100,000 events in baseball, basketball, football, hockey, 66 leagues in soccer, and every North American horse race. We did that not just before the game. We did that as we got new information around injuries, et cetera, and during the game. Aside from horse racing, we obviously didn't do it mid-race, but for all the other sports, during the game, after every play, and we never had more than 6 employees. Automation is the key to scale. The way that we handled our data, the way that we automated things was the way in which we were able to grow. And very last on this list, but not least, find the so what. Data without context means nothing. Data science without understanding and driving toward an impact is useless. Find the so what, identify the so what, and work toward a so what. In fact, my recommendation generally when thinking through a data science problem is not to start with a data set and work towards a solution to some problem that's yet to be defined. It's to think about the impact first, identify the output that will address that the impact of a solution, think through then how to get to that output, and then identify throughout that and then get to a point where you understand what is the information that exists to best help me solve for that. Because if you don't have a clear line of sight to impact to solving a problem using data science, you're ultimately going to do work with very little with very little return on the investment that you put the time in. Why does sports matter within any of this? Why am I talking to you now? Why is this insurance guy who was a consultant who went to UC harping about sports and how we can learn from sports? Well, I think sports is the ultimate catalyst and, in honesty, proving ground for data science. And there's a clear few reasons why. One of those, wealth of data. It's ridiculous, but it's also true that I can tell you with reasonable certainty that I know what happened in the bottom of the third inning when the 1897 Cleveland Spiders hosted the Baltimore Browns. Like, that was recorded. And so there's no lack of data, not just in terms of the day-to-day now when we have cameras tracking every player movement in soccer and basketball, the ball, the speed of the pitch, the spin rate, when it comes to baseball, chips and shoulder pads for every movement that you can find in football. Yes, we have a wealth of data on a game-to-game basis, but we also historically have a wealth of data. And all of that data is actually tied back to an outcome. And so the immediacy of the results in sports, the fact that we have outcomes, the fact that we have clean outcomes and clear, definitive outcomes really helps make sports a good proving ground for data science. Now, as you'll hear in a couple slides, I am certainly about process over results. So when I talk about outcomes, I talk about large sample size. But on a day-to-day basis, we can within sports test out different theories around data science, potentially come up with solutions, and identify whether or not those solutions are impactful or accurate very quickly because of the sheer volume and the sheer volume of games and the definitive nature of an outcome. Along those lines, meritocracy. I like to believe in meritocracies, especially in the data world. Meritocracies have an assumption of objectivity in coming up with what merit means. And sports is the ultimate. It's the closest thing to a true meritocracy that we have, because there are winners and losers in every game and ultimately over an entire season. Sports is also culturally significant. A lot of people know about it. So using it as a proving ground for data science concepts makes a lot of sense. When things like Moneyball happened with the Oakland A's in 2004, and a team that doesn't look like a normal team is constructed on a low payroll and ends up succeeding, then there are culturally significant ways to be able to point toward that and really drive home the value of the kind of work that they might have been doing with the Oakland A's back then, and the kind of work that data scientists have been doing since then, because most of the concepts that exist within data science have had some kind of opportunity to be proven within the sports, or at least within sports, or could at any point in time. Important lessons learned. How does sports apply to business? I used to always, right off the top of any conversation, whenever I would talk about the value of data science, I would reference the fact that outcomes in the past, that have not occurred in the past, can be predicted in the future, which breaks a lot of people's brains. But sports is the perfect example of that. You know, the Baltimore Ravens and Indianapolis Colts, who played against each other in football last night, had never played on a Monday Night Football with that exact, 44, with those exact 44 starters, with those exact coaches, with that weather, with that crowd, in that weather condition, or excuse me, in that time condition, Monday Night Football, et cetera. But we can take the components of all of the pieces of what was about to happen, compare them to each other to try to identify what should happen when the Baltimore Ravens and Indianapolis Colts get together for a Monday Night Football game. Just because something has not happened in the past does not mean it cannot be predicted in the future, especially if general probability, if there are ways to understand the likelihood of components of an event occurring that would be indicative of a larger event occurring. Consider the impact. We just talked about this a little bit. Impact, not just the problem or the data. Starting with data or starting with the problem means less if the impact of a solution using data is not fully understood. Focus on what matters, really critical to understand, and sports is a great example of this, but avoid the traps of oversimplification. We'll talk about these two examples of that here in just a second before we get into a couple of sports applications. Process over results. In sports, there are many great examples of bad process, good results, but over the long run, good process equals good results. And so it is easy, especially in the business world, to get discouraged or to chase results and overreact to results, despite, in general, regardless of the process. A process is key to ultimately getting long-term best results. And I mentioned this last one, I can't stress it enough. Without context, data and data science means essentially nothing. I want to give an example of how simplification is valuable, but then I want to talk about how it can actually be abused. Look at basketball. When I was writing my master's project in the, what was at that time, the quantitative analysis program at UC, I read a book called Basketball on Paper by Dean Oliver. And this slide basically, and really just the left hand of this slide, the three ways a possession can end, really turned a light bulb on for me as it relates to data science. Because I realized that the game, even though you've got 10 players moving at all times in the game of basketball, you have one ball in the middle on the court, you have 3 referees and tens of thousands potentially fans in attendance, that there's really only a few things that matter to try to figure out what's happening and what is going to happen. A possession in basketball can end in only one of 3 ways. Either somebody shoots, somebody gets fouled, or there's a turnover. Technically, when somebody shoots, if there's a miss, that same team can get the rebound and the possession can, whether you call it extend or restart, doesn't necessarily matter for this conversation, but ultimately that's one other thing that can happen. That's it. That's basketball. As soon as I read that, I realized that solving problems using data is feasible, is possible, and that it could be explainable, and it could ultimately gain the ubiquity that we've seen it today. And at least hopefully is definitely when it comes to sports, because we were able to take a game that's free flowing and fluid and simulate it or predict based off of knowing just 4 things. Now there's 2 teams, let's call it 8 things, still a very limited sample or limited amount of information. We know how well a team shoots. We know how often they turn the ball over. We know how often when they miss a shot, they get their own rebound. And we know how often they're fouled and, they turn that into free throws. Just knowing those things offensively and defensively, we have a very good sense then as to everything that could occur over the course of the game. 98% of predicting a basketball event is just knowing those things. And just about anybody who looks at those numbers for 2 teams that are playing against each other that have a decent sample of data that is indicative of what those numbers should be, just knowing those numbers, most people could look at and understand at least who's likely to win. The only things that kind of differ there, obviously injuries, home court advantage plays into all of this, obviously a little bit, but and massive height or size differences. So that's usually in the data somewhere, especially at the collegiate professional levels. 2 important things to note, that when it comes to these 4 factors, the best team, like literally the team that should beat the most amount of opponents, is the one with the fewest weaknesses in these 4 factors. But an upset occurs when a team that is not great at all of them, but is really good at one of them, can exploit a weakness in an opponent that might find a weakness that might be weak in that same area. So that's how simplification is good. That's how looking at a problem and realizing and feeling like it's daunting, but then realizing there's just a few things that really matter is valuable. Oversimplification. Somewhere along the line, and I don't know who did it, and I don't necessarily want to try to put somebody in that spot, it was an all-encompassing, all-consuming metric was designed with the intent to be able to answer question, if I plug one player onto one team, what does it mean? And how better am I going to be? And wins above replacement became the metric, or conceptually fine. I don't love it, but it's fine to think that if all players on the exact same plane and we can plug a player and we can plug players in, how should that player on a new team be able to perform? Fine to think about, but executed incredibly poorly, because the calculation ultimately puts everybody on the same plane, independent of context. So if you hear wins above replacement, it's usually just this player helped contribute a certain number of wins to his team. That is lagging. That is that he did that, and that he did that just with his team. It doesn't mean, though it's usually blindly followed to assume to be predictive, it doesn't mean that taking him off of that team and putting him onto a new team should do the same thing. There's significant issues with that. First of all, the context, strength of schedule, baseball, if we're talking about this, where WARs really seems to be a significant metric that's used by most teams. In baseball, every field is different. certain fields like Coors Field at its elevation are more conducive to offense. Certain fields like Petco Park, which is Coors Field being in Colorado and Denver, Petco Park, or not, it's not Petco now, but the San Diego field is at sea level and is not conducive to offense. There's definitely ways to look at whether a player or what a player can contribute that can be predictive. But the way in which something like WAR, theoretically an all-consuming metric, is leveraged is very different than how it should be used, because it is a lagging metric that identifies what did matter and how did this player perform under circumstances that are not contextually compared to the circumstances of all the players. To be predictive, and I have this in the notes, so when this presentation gets slide, if somebody really wants to dive into this, you can. To be predictive, it's important to understand, okay, how can that player contribute? That player contributes on a per play basis. And if you compare what he does in a neutral environment with a neutral team against a neutral opponent, that's the closest thing you can get to being predictive. But still, it's important to then plug him into those scenarios and see what happens. That's why I did simulation with Prediction Machine, because simulation allows for all those contextual concerns to ultimately be resolved simply by putting several different interacting forces together and seeing what an outcome could look like. I want to talk about some examples here. So we'll spend the rest of our time getting into some stories to tell and some examples. I know we got about 15 minutes left in the conversation, but what are the applications from sports to business? First of all, players are predictable. Everything I just mentioned, there's a general arc to how a player performs over time. And any wavering from that is ultimately usually noise. Well, it's very similar to customers. Customers on an individual basis can think and feel as though they are unique, but oftentimes, especially in aggregate, they function similarly. Predicting players, predicting customer activity, fairly similar. Who to hire, who to sign, who to bring on board. As you'll see here, as I already alluded to, the sports world or data science was very helpful in bringing on Luke Fickell, the head coach of the University of Cincinnati, and using a lot of his underlying metrics to help to understand whether or not he was the right hire for the team. From an HR perspective, that can be the same thing. People tend to play to the back of their baseball cards. That really applies to both of the first two notes on here. But that was a saying that I heard oftentimes in sports media. Players play to the back of their baseball cards, meaning that who someone is tends to be who they are. And though we can evolve, even those evolution curves with experience and with age are fairly predictable. So over time, understanding the missing pieces, who to hire, who to sign, how those people or players for sports interact can be predicted. And then where do we have the right to win? How do we win? What matters? What drives revenue or profit? Those are all things that we have sports examples for that obviously apply to business as well. A couple then of those examples, fairly hopefully valuable anecdotes here. I tried to identify what technology was used to be able to determine not just technology, but what models were used to be able to determine the things I'll show in these final three examples. Example of regression. This is, in all honesty, a multivariate regression, not incredibly difficult or sophisticated, but ultimately very useful to the Reds use case. Important for me to note, I personally don't like black box metrics when actually dealing with business problems where understanding the why is just as important to the actual accuracy of the model. And so regression is something that, or an ensemble model that has regression as a part of it, is something that I do still focus on considerably. And with the Reds, we took data from a large sample size of Reds data for single game tickets. So their season tickets are sold ahead of time and have a retention rate in the 90+ percentile range. But and so those are fairly static, or not necessarily static, but fairly predictable year over year. Whereas single game tickets fluctuate incrementally day in and day out. And some of the interesting things that we found when running regression to try to understand what are some of the things that will predict how many tickets are sold, we figured out that certain things are predictive. Obviously, the day of the week. More people come on Saturdays than Tuesdays. Makes sense. More people are available and have some time on Saturdays than Tuesdays. Giveaways, bobblehead dolls. Having a bobblehead doll on a game day increases the ticket sales by about 50%. Significant increase in the overall ticket sales. Reds performance. I thought this was fascinating. So when doing this analysis for the Reds, we tested about 20 different metrics that were all associated with Reds performance. The degree to which the fans thought they were in contention, which is a really weirdly worded phrase that I'll explain in a second, is predictive of whether or not people will come. And what that ultimately, the metric that was best able to illustrate that was playoff probability by a company called Fangraphs is the best one to bring in for this data. How likely the team was to make the playoffs was ultimately predictive of how many fans would come to the game. So even though every fan doesn't wake up and think, hey, we have a 13% chance to make the playoffs, they do know we have a decent chance or we don't have any chance or we have some chance. And that was representative in more fans coming to the game. Opponents, the Cubs basically double the attendance of the game. Weather, the only things that really mattered is if it was too cold or if it was raining before the game. Actually raining during the game didn't really matter to predicting whether people would come to the game. But if people looked out their window and saw that it was raining or saw that it was under about 55 degrees, they weren't interested in buying tickets, or at least that's what we found. Further into the season, less sales, holidays, some holidays were good, some were bad. Some drove up attendance like Father's Day, and most Monday holidays, some like Mother's Day and Easter drove tickets down. And one of the most interesting things I found that I think is directly applicable to a lot of use cases is that since the Reds were not usually hitting their predictive or their possible ceiling of tickets sold, peak on peak was more valuable than anything else. Meaning bobblehead and concert and fireworks could sell a game out and exponentially sold more tickets than any one of those things independently. That was really fascinating to me, and I've become a huge proponent in other analysis that I've done in the marketing ROI world with some of the consulting. That peak on peak, again, when there isn't a fixed ceiling on what you can sell, or at least in this case with the Reds where you're not hitting it, peak on peak was really valuable. Price, I gave a speech along these lines in an MLB convention with every team represented, and the A's mentioned to me that they once gave all of their tickets away for a game, literally gave 120,000 tickets to a stadium that seats about 40,000, and they got 30,000 people to come, which was more than usual. So free matters, but at least in the Reds analysis, any of the pricing options that had ever been sold were not the highs and lows, basically the reasonable range of tested options were not predictive of future sales. None of the other things, at least that are listed on here, ultimately were predictive either, which I thought was fascinating. Especially as it relates to like giveaways, where bobbleheads was huge, other things weren't. Let's talk about a simulation example. I mentioned that things in the future can be predicted even if they haven't happened in the past, and this is a great example of it. There was essentially a 3-person committee to identify and then ultimately hire the college football coach of the University of Cincinnati football team. Back in 2016, it was Brandon Sosna and Mike Bone. Brandon Sosna was the chief of staff for Mike Bone, the athletic director, and all credit to them and Luke Fickell himself for bringing me on to try to simulate what does the next 4 years look like with UC football, given each of the different head coaching options. They gave me 10 coaches. They called me the day that Tommy Tuberville resigned. They gave me 10 coaches to evaluate. 3 of them took jobs basically in the next 24 hours after that was handed to me. One of them immediately said no, and then ultimately still went on to go get a different job. And so we only really had 6 or so to play with, and none of them were really testing well on our numbers. And so aside from Scott Satterfield, who is listed on here, who's now at Louisville, and was at Appalachian State at the time, but Brandon and Mike just reached out to me and said, who are we missing? And I said Luke Fickell. Urban Meyer also called them around that time and said, hey, you should talk to Luke Fickell. So I'm not sure exactly how much of a role that phrase meant. But when we dug in and did the analysis, we evaluated that based on his scheme, based off of how few mistakes his team made as a defensive coordinator over a decade at Ohio State, based off of how he developed players and the talent that they ultimately had and how they were and the awards they received and how they were graded, and based off of his aggressiveness, which is undervalued in sports oftentimes because coaches feel as though they're motivated by keeping their jobs, which makes sense, but it also means that they tend to coach to the fewest amount of controversial calls as they possibly can, so that they have fewer questions and fewer scrutiny and less scrutiny. And in that case, unfortunately, while aggressive strategy in sports, especially in football, tends to win, it doesn't tend to be what we see with coaches. But we had seen, at least in the minimal experience with Luke Fickell in his defensive coordinator and one season as a head coach, that he was aggressive enough to likely succeed in this space. The numbers that you see on here are totally legitimate. I filed a paper or a presentation to the athletic or to the board of trustees that said that over the first 4 years, which we've already gone through, we expected that a Luke Fickell University of Cincinnati team would go 34-14, have a very high likelihood to win the conference, score 28 points a game, and give up 21. I'm very happy to say that they definitely won the conference, that they scored more than that, and that they won an extra game because they went to one more AAC championship than even I was predicting at the time. So that there's a conference championship game in there, plus a bowl. So don't always expect the results to be that perfect, but ecstatic to see that it happened. One more quick example as we're wrapping up here. Understanding the problem. So I teach bracketology or taught bracketology at the University of Cincinnati for 5 years. Didn't touch on that too much in my intro. That was a class we gave credit and it was fun, but hopefully everybody learned a lot as well. And one of the things that I think was really interesting that we talked a lot about was how a problem can essentially have two completely different, or how a topic can have two completely different perspectives. Both are accurate, but how imperative and critical it is to look at them through the appropriate lens. For instance, when the selection committee for college basketball tournament goes about seeding the field, which we actually had everybody do as well in groups of 10 in our bracketology class, they're looking at who's deserving based off of record, strength of schedule, to some degree brand, because they want to set up appropriate matchups, certain seeding rules, how a team is playing recently, their own biases. That's all in there, and that's fine. But that has literally nothing to do with who's going to win, because ultimately who's going to win is about style and matchups and talent and health and the path that they have to ultimately play beyond just the next matchup they have and how efficient someone is or a team is. And I think that there's very few, this happens in college football as well, when we get to the point of a college football playoff discussion, there's very few better examples of how different two perspectives can be when the topic feels like it's trying to answer the same thing. The committee is trying to figure out who's most deserving. They'll use the word best, but ultimately they default to most deserving. Record matters, strength of schedule matters. That means very little when thinking about best. The players, the coaches, the styles all matter when you're actually trying to figure out who's going to win. There are countless applications of that same exact concept of thinking about process when really trying to figure out what's going to happen versus results, in this case, rewarding what has happened. A lot of other examples, never intended to get into these over today's conversation, but sports has definitely shown and shined a light on a lot of different kind of not just business lessons, but life lessons that can be powered by objectivity and leveraging data and technology. As a reminder, just to kind of wrap up with the the same thing that we touched on before. Outcomes that have not occurred in the past can be predicted in the future. Always consider the impact of a solution, not just the problem you're trying to solve or the data that currently exists that can help you solve it. Focus on what matters, but avoid the traps of oversimplification. Process will win out in the long term over results. Do not chase results just because of their results and they're promising. And data without context means nothing.